Good morning, friends. Is the screen visible?
Yes, sir.
So, last day I have ended my lecture with the statement of uh, verification of divergence theorem. So, it is a statement of if a vector A is there, any vector, A could be the any vector, any type, then left hand side of it tells you that it's the surface integral of that vector around a closed surface. A dot ds, surface integral of that vector around a closed surface. And right hand side tells you that volume integral of divergence of that vector. Volume integral of divergence of that vector. And these two sides are essentially equal. This is the statement of the divergence theorem. And so let us solve one problem to validate this statement, divergence theorem. Suppose we have a vector A is equal to 2rz square ar cap plus r az cap. This is a vector. Now for this vector you need to verify this statement. Okay. Now, the statement of this vector verify divergence theorem for the vector this for the surface defined by some ranges are there. Okay, so that range is given by 2 less than equal to r less than equal to 5. This is the range for r. Range for z will be -1, that will be is equal to z less than equal to 1, and the phi range will be uh, 0 to 2 pi. So this is the range for the vector. This is the range of the surface. Okay, where r varies from 2 to 5, z varies from -1 to 1, and phi varies from uh, 0 to 2 pi. So this is the range of the surface. Now, in this statement, let us see how this is means how this vector can be used to implement or to verify the divergence theorem on both sides. Okay. Now, the first immediate question comes. First immediate question comes that um, now what do you mean by this actually? These three ranges. What do you mean by this? Now, as per the problem itself, you can understand that this vector is given in cylindrical system. This vector is given in cylindrical system, right? Because r and z, perhaps you could have found in it in cylindrical system. So this is cylindrical system. Now you have to look at this diagram or this range. Now you have to figure out then using three these three variation, what kind of geometry it will be evolved, what kind of geometry will be evolved out of these three range. So if you draw xyz axis, okay, if you draw xyz axis, this is x, this is y, this is Z. So your first if you look this one first, then it's 0 phi rotates. uh, okay, let us coming to first. Am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Okay, so let us first to this. You see, R is varies from 2 to 5. So let us say this is 2 and this is 2 radius and this is 5. So whatever be the geometry persist is between 2 to 5. Nothing outside, means nothing beyond this zone. Okay. Now when you go to the 0 5, so it rotates the entire thing. 0 to 2 pi means it rotates the entire space. It's like this. Okay. It's rotating, it's like this. 0 to 5. It's like a circle. And if you look at this range for Z, so it is basically it goes like from -1 to +1. So if you use a 3D figure, it's like this. It's a hollow cylinder. It will form a hollow cylinder. It will hollow cylinder. So there is a definite solid part in it. I don't know whether my diagram is so much convincing or not, but still I want to make you. So it will be a hollow cylinder, not a solid one, but it will be a hollow cylinder. So everything. So the black shaded regions are solid, and the blank regions are hollow. Is this diagram is okay with you, or are you okay with me this logic, or any disagreement or any other opinions? You are feel free to share your views, please. If anyone has having any difficulty or any disagreement to this, you please share your views. You can share your views. So it will be a structure like this. It will be a hollow cylinder. It will be a hollow cylinder like this. Please, anyone having any doubt? So if we use this ranges 2 to 5, -1 to 1, and 0 to 2 pi, then it will form a hollow cylinder like this. Now I want to make a mention here that if this range of R start from 0 to 5, then it will be a solid cylinder. It will be a solid cylinder. Okay, it will be a solid cylinder. So uh, due to the 2 to 5, so as I told you, there is nothing beyond this region, nothing physical medium beyond this region. So it will form a hollow cylinder. So first question comes, you please clarify your doubts at this point, if this diagram is okay with you or not. If this diagram is okay with you or not.
Yes, sir. Okay.
Okay, now if it is okay, then my next question, that how many surfaces are there? Can you tell me how many surfaces are there?
One, sir.
Three
No,
surfaces.
Sir, three surface.
no. Who said 3?
স্যার আমি বললাম।
Can you justify which those
Sir, four
surfaces?
surfaces. Sir, four surfaces are there.
So
ফোর
three
সারফেসেস স্যার।
three surface. Why 4? Can you justify your answer?
স্যার যে হলো সিলিন্ডারটা আছে তার দু সাইডে দুটো সারফেস যদি ধরেন আর উপরের পোর্শনে একটা সারফেস ধরেন আর হলোটার ভিতর দিক দিয়ে একটা ধরলে টোটাল চারটে সারফেস হচ্ছে।
So you are telling the three. You are telling about 3 surfaces. One surface you are telling
Sir, I'm telling about four surfaces.
you have counted 2 times. So you are actually telling about 3 surfaces, but you are counting at you are counting it 2 times. So that's why you are telling 4 times. You are telling 4 the answer. Please again justify your answer. What are the 4 surfaces?
Sir, if it is possible, may I talk to you Bengali?
হ্যাঁ হ্যাঁ অবশ্যই।
স্যার মানে যে হলো সিলিন্ডারটা আছে আপনি সিলিন্ডারটা
Yes.
যদি বাইরের সাইড দিয়ে ধরেন তাহলে একটা সারফেস হচ্ছে, আর যেহেতু ওটা হলো আছে ভিতর দিক দিয়ে ধরলে একটা সারফেস হচ্ছে, তাহলে দুটো
Okay.
হচ্ছে। আর যদি
Okay.
বোথ সাইড দিয়ে ধরেন মানে সিলিন্ডারটার দুটো সাইড মানে দুটো এন্ডের দিকে এই সাইড রাইট সাইডে একটা সারফেস এন্ড লেফট সাইডে একটা।
No, your answer is not convenient. But maybe you understand, but you are not making us understand. So your answer is not accepted. Your logic is not right. Anybody wants to tell? Any other person wants to try? Anyone? Anyone? So who is telling 3 surface? Is it Pritam Datta?
ইয়েস স্যার।
So your justification, please tell me.
স্যার স্যার সারফেস মানে স্যার আপার পোর্শনটাই বোঝাচ্ছে, তাহলে স্যার একটা মানে দুটো লেফট সাইডে স্যার যে সার্কেল দুটো আছে ওই ওই ওখানে ধরলে দুটো সারফেস আর ওপরটায় একটা সারফেস, তো সেক্ষেত্রে স্যার 3টে সারফেস হচ্ছে।
No, your answer is not convincing. Okay, I am telling you the answer. Anybody else? I am giving you the last chance. Anybody wants to give any try? Anyone wants to try? Okay, you see, uh, this is a hollow cylinder. So you see, you must. It is this portion is only solid. This portion is only solid. So there is a vacant area outside this region. Okay, there is a vacant area. So throughout this body, you see the entire thing is curvature. Entire thing is curvature. So one surface will be acted in this direction. In this direction, air cap, and this inner surface, this inner one is having another surface. The inner one having another surface which is directed along minus air cap. Minus air cap. So now at this surface which is directed along positive air cap, this is equal to r is equal to 5. This is at r is equal to 5, constant r surface, and this inner surface, that is the curved surface which is there, which is directed along minus air cap, it is at, that is equals to at r equals to 2 surface, and it is situated at r equal to 2 because this is the region or this is the range. You understood? And apart from these two, there are two more surfaces. One surface is this roof, which is acted along positive AZ, this is at z equal to one surface, and another surface is acting at bottom, which is acting along this minus AZ direction, and this is at z is equal to -1. So altogether there are four surfaces acting, or four surfaces exist. So these four surfaces maybe you all are thinking of, but you could not able to express yourself. So these are the four surfaces. Now why I have mentioned it is directed along air cap, because this surface, whatever this outer surface one, it's represented in green, outer surface, the border line, it's green. It can move in this direction. It cannot move in backward, because backward is it's in the reverse direction. It is in the solid zone, so it cannot be moved in the reverse direction. So one way you can move it in the forward direction. So this direction has to be air cap. On the other hand, this surface, which is drawn in by black, the surface, it is by the same logic, it is acting along minus air cap. Minus air cap, because in the positive direction it cannot move. Similarly, this roof, this roof, this that means this portion, this means this portion only, this can be moved upward. This can be moved upward. So it will be acted along AZ cap, and it is the geometry of the surface is equal to constant Z surface, and Z is equal to 1, constant at 1. And similarly, this bottom surface is acted along minus AZ direction. So it will be acting along minus AZ direction, and it is again constant Z surface. So it will be this surface is the equation of the surface is equal to Z is equal to -1 as per this ranges of available, as per the statement of the problem. So is this okay, or any disagreement? Please tell me. Is there any disagreement? Please tell me. Anyone, anything? Any question? So if there is no question, then can we move forward? So let us solve the left hand side first. Let us solve the left hand side first. Left hand side is equal to uh, it is the closed surface, that will be equal to A dot ds. So this is the equation. So since we have four surfaces altogether, so we disintegrate this equation, or this integration, into four parts. First one, we shall be doing A dot ds1. Second part, for integration for That's why 4 surfaces, that is why 4 integration, separate integration, discrete integration, a dot ds2. Hard part will be a dot ds3, and the fourth part will be a dot ds4. So we name one by one. That will be is equal to I1 plus I2 plus I3 plus I4. So let us evaluate one by one. Is it okay with you all? Is it okay? Let us evaluate I1 first. So it is a dot ds1. Now what is ds1? So we have to consider one surface, one particular surface at a time. One particular surface at a time. So we treat this surface as S1. We treat this surface R is equal to 2 as S2. We treat this surface as S3, and we treat this surface as S4. So 4 surface we treat separately. Okay. So let us say what is S1? It is a constant R surface. It is a constant R surface. Now if you go back to your differential line element, differential surface element, differential volume element, it is not in this note. So if you search your note, then you will find out that your differential, okay, let me write it down, DSR that will be is equal to R d phi R d phi and dz AR cap. If you go and search to my or any note, you will get this DSR. This was the equation. Yes. Is one having any question, please? Sushanto Mondol. Do you have any question? Sushanto Mondol, do you have any question? Hello? Am I audible?
Yes, sir, you are audible.
Yes, sir.
Yes,
Sushanto Mondol, you are raising your hand. If you have any question, you can ask your question. So if you, what I was telling that if you go and search your previous note, then constant R surface, the mathematical equation of constant surface was this: R d phi dz A. It's not AZ cap, it is AR cap. It is AR cap. Okay, this was the equation. 1 minute, I need to take a phone call. Just 1 minute. Yes, what was I telling that this was the equation. So DSR is R d phi dz AR cap. What is A? You know, A is 2R z square AR cap. It is 2R, sorry, let me put the integration first, then 2R z square AR cap plus, then what was next, R AZ cap, R AZ cap. So this was the vector A dot ds1. Now ds1 means this part first, R d phi dz, R d phi dz AR cap. Okay. Now to integrate this uh, equation or this expression, you need to place the limits. Now this is, you know, this is a constant R surface. So what is the value of R? As I already told you, R is equal to 5. So you can straight away write 5. So who are the two other variables? It is d phi and dz. Okay. So you can place your variables limits here. Phi, as you know, it is 0 to 2 pi. 0 to 2 pi, and z, as you know, it's the range -1 to +1. It's the limit. Z is equal to -1 to +1. So this is the expression for you for the integration. If you have, please go through this equation. Please, if you have any doubt, you can ask me. A, this is A dot ds1. So A is this much, I as it is written here, and ds1 is nothing but dsr as it is written here, and this dsr is nothing but r is equal to 5. This is constant R surface. So is it okay? Please go through this very carefully. 1 minute break. Is it okay? Please. Hello, am I audible?
Yes, sir. Yes, sir.
Yes,
Okay, sir.
sir.
Okay. So you need to please respond. So if you now, next step is the dot product. You know AR dot AR1, AZ dot AR is 0. So this part will no longer be active anymore. This RAZ component, because AZ dot AR is 0. So you forget about this part. Now you AR dot AR is 1, so you straight away write integration limit phi to 0, phi from 0 to 2 pi, z from -1 to 1, -1 to 1, then it is coming to 2 r square, 2 r square z square, 2 r square z square d phi dz. Okay, and which is to be integrated at r is equal to 5. So r is constant here. So you can, in the next line, you can take that one outside. So r square means 25, 25 into 250. So if you integrate d phi, then it will be 5. So it will be 2 pi if you put limits. and if you integrate z square, it will be z cube by 3. It will be z cube by 3. So if you put your limit, then it will be 2 by 3, I think. So altogether it will be 200 pi by 3. It's the answer. The integration of this first part, first surface, it's 200 pi by 3. So please give a response whether this is okay or you have any doubt, not understanding anything. So is it okay? Please go through this.
Okay, sir.
Now similarly, if you conduct I2, if you similarly conduct I2, I will not doing it in details because the integration type is same. Now this is ds2, so the integration limit will be same. Phi is equal to 0 to 2 pi, z equal to -1 to 1. So your vector is 2r z square ar cap plus r az cap. Now if I am putting DSR, now a slight change will be there. R d phi dz. Now in this case, it will be not AR cap, it will be minus AR cap. It will be minus AR cap. Why? Because I have already told you that because constant r is equal to 2 surface, which is I have defined as S2, symbolized as S2, it is directed along minus air cap. So the equation remains same, but the direction remains minus air cap. So you need to place them accordingly. And this is done at constant at 2. So everything remains same. Others are everything are same. You see, if you multiply it 2r square, so it will be now r is equal to 2. So r square means 4. So you take it 8 outside. So if you put limit phi is equal to 0 to 2 pi, z is equal to -1 to +1. So you have taken r square, 2r square outside, so it is 8. So it is z square, obviously with a minus sign, definitely, because this is minus. So z square d phi dz, z square d phi dz. Okay. So if you calculate, so it will be -8, that multiplied with 2 pi and then 2 by 3. So it will be, answer will be -32 by pi. Answer will be minus 32 pi by 3. Sorry, not 32 by pi. The answer will be 32 pi by 3 with a negative sign. So this will be two answers. The first integration will be evaluated as 200 pi by 3, and second integration will be evaluated as minus 32 pi by 3. So please tell me if you have any question.
No, sir.
So it's good if you do not have any question. I hope it is okay with you. Now,
Yes, sir.
so if you coming to the I3, the third integration, there are limits. Let us first write the vector 2r z square ar cap plus r az cap dot, this is a, this is nothing but a. So now let us write ds3. ds3. Now ds3 is nothing but, ds3 is nothing but, as you can see from the diagram, ds3 is nothing but constant z surface, constant z surface, and it is mathematically equal to be dsz. It is mathematically equal to, if you go back your previous note, it will be equal to r dr d phi, r dr d phi az cap. So this is the equation for dsz. So let us write it down. So dsz, so which is equal at ds3, so it will be r dr d phi a z cap, and it will be evaluated at z equal to 1, because ds3 we have considered to be z is equal to 1. So let us evaluate this integration and put, let me put the limit r. The limit for r will be 2 to 5, and limit for 5 will be 0 to 2 pi. Zero to 2 pi. So this is ds3, nothing but ds3. So if you evaluate, then it will coming as you know, now this component will be vanished, because ar dot az will be 0. Now az dot az will be 1. So it will be nothing but r square dr d phi, r square dr d phi. If you put the integration limit, then it will be r is equal to 2 to 5, phi is equal to 0 to 2 pi. So this will be is equal to r cube. Now if you integrate r square dr, So it will be r cube by 3. So it will be 100 17 by 3 into 2 pi. R square, so r cube by 3. So it will be 234 by 3. R cube, 5 cube is 125.
Sir, ठीक है sir. 78 pi answers.
Answer will be 78 pi.
Yes sir.
Okay, then you are telling. And similarly, the same integration I for I4 as well. Let me first put the limit from r is equal to 2 to 4. Pi is equal to 0 to 2 pi. So this becomes a 2r z square ar cap plus r az cap dotted with r dr d phi. Now in this case it will be minus az cap because it is acted along negative direction, negative z direction, and at this it will be equated at z is equal to -1. So essentially this is a, this is the a vector, and this is ds4. This is ds4. So if you equate them, then it will coming as r is equal to r is equal to 2 to 5. Pi is equal to 0 to pi. R square dr d phi with a negative sign in front. So it will be evaluated as minus 78 pi, I think. So at the end of each iteration, at the end of evaluating all the integration, so if you evaluate the total left hand side, I, that will be equal to all summation of all four, so it will be coming as 200 pi minus 32 pi, 200 pi by 3 minus 32 pi by 3 plus 78 pi minus 78 pi. So answer will be 56 pi, I think. So please check. Answer will be, I think, 56 pi.
Yes sir. 56 pi.
So this is the left hand side, evaluation of the left hand side. This is the half done. This is the half problem done. Okay. So this is the half problem done, and the answer would be 56 pi. Now we have to verify this 56 pi, whether we have to integrate right hand side integration, and we have to check whether right hand side value is 56 pi or other. So if it is a 56 pi, then we can say that this divergence theorem is verified. So let's do that. Let's do that. What is the statement of right hand side? What is the statement of the right hand side? Is the volume integral it is the volume integral v, that is the, then we have to take the divergence of that vector del dot a into dv. Now you know divergence of any vector in general form, you can if you recall 1 upon h1 h2 h3, as I told you, please memorize the general form. Then what was it? Let me see. Del del u1, okay. Del del u1 del del u1 a1 h2 h3 a1 h2 h3 plus del del u2 h3 h1 plus del del u3 a3 h1 h2. So this is the generalized statement. So if you put the values, exact values, so h1 h2 h3, it will be 1 by r. So the first term will become del del r. Now what is a1 h2 h3? Now in this case a1 means what? A1 means this one, 2r z square. So 2r z square into r. So 2r z square into r. So it will be 2r square z square. Plus del del phi, you know a2 is 0. So this term will be cancelled. No need to write it down. So last term will be del del z a3. Now h1 h2, that means h1 h2 means r. And what is a3? A3 is nothing but r. A3 means r, only r. So r into r, so r square. R into r, so only r square. So ultimately it will be coming as del dot a, it will be coming as, you see, this term will be 0 again. So it will be coming as del del r, so 2r, 4r z square. So 1 by r into 4r z square. So it will be 4z square. Is coming out to be 4z square. So this is the divergence value. Now in cylindrical system, what is dV? You know it is r dr d phi dz. R dr d phi dz. So you what? So your right hand side will be evaluated as triple integration. You first put your limit r from 2 to 5, 5 from 0 to 2 pi, and Z is from -1 to 1. So it is R dr, sorry, let me first write this del dot A term. So del dot A is 4Z square. 4Z square 4Z square into 4Z square into this dv term. So dv is R dr d phi dz. R dr d phi dz. So this is the complete expression for this term. So if you evaluating now, if you start integrating, so 4 you take outside, so r dr, so it will be r square by 2, 4 multiplied by r square by 2, you place limit from 5 to 2. Then coming to the phi term, phi d phi integration phi, so you place limit to pi to 0. Then your last term z square, it will be z cube by 3. So you place limit 1 to -1. So 4 multiplied by, now r square by 2. So it is 25 minus 4. So it is 21 upon 2 into 2 pi into 2 pi 3. So what is the answer? This 2 cancels. It is 7. So 4 into 7 into 2, 56 pi. So as it can be seen, so right hand side is also coming out to be 56 pi. So in this way, the statement of the divergence theorem is verified. So you please go through now. If you have any question, you can ask me. So the problem, the same thing is done in this problem. It is exactly the same thing has been done here. Let first evaluated I1, then I2, then I3, then I4, then integrating all to evaluate left hand side, then evaluating right hand side. So everything has been done. So you can verify, you can go through this problem at home. Okay? Is there any question on divergence theorem?
নো স্যার, স্যার এক্সামে কি এরকম প্রমাণই আসবে?
Let's not talk about that because it's all dependent on the situation of my mind. And what during the setting, during that time when I set the question, what I think it matters most. If now I say that yes, this type of problem will come, but eventually if not come, then I don't want to do any promise on that. Okay, it all depends on that time, what I am thinking, what I want to give at that time.
Okay, sir. Okay, sir. Okay.
But yes, since this problem or this paper is a mathematical paper, it's not a theoretical one, so you can expect bulk of the questions are should be numeric type.
Okay.
You can expect bulk of the question are should be of numeric type. Okay, you can expect that.
Yes, sir. Yes. Okay.
Oh, any other question?
No, sir.
So now let us quickly go to our next topic. It is Stokes theorem. Stokes theorem, another very important theorem. Now, in case of divergence theorem, it was the statement A dot ds del dot A dv. So you can see it relating. It is relating this statement of this theorem. It is relating surface integral to the volume integral. Now, in case of Stokes theorem, it will relate line integral into surface integral. So the statement is like this: if any vector A, its line integral around a closed line that will be equal to surface integral of curl of that vector. So this is the statement. This is the statement. Okay. Stokes theorem. It is relating line integral to the surface integral. So if any vector A, its line integral around a closed line, closed loop, that will be equal to the surface integral of curl of that vector. It is curl del cross A. It is the curl of that vector. I have not having any problem. Maybe so next day when I come to the class, I can discuss this.
স্যার স্টোকস থিওরেমের পিডিএফটা পাঠাননি তো আপনি?
Sorry?
স্যার স্টোকস থিওরেমের পিডিএফটা পাঠাননি তো আপনি?
No, actually, in other years, the Rimi madam will take up this topic. So that's why I have not prepared this Stokes theorem. So I will give you. That is the problem. This year I take this topic. So I will share you.
ওকে স্যার, ওকে।
Don't worry. So if you have any question, you can please ask me. I'll continue from this one, Stokes theorem. So if there is no question, then I can end my session here.